Good morning, everyone. Has everyone had their coffee? Still having their coffee? Still waking up? Someone needs a punch in the face? Okay, at least that, hopefully that woke it up. Okay, everyone, welcome to the, I guess, the first or second day of the Data Plus AI Summit. Everyone here is clearly brave enough to attend the first session and not sleep. So thank you very much. Extra thank you for coming in this first session, especially to those who are not morning people. That includes me. So here today we are going to talk about the Unity Catalog open source project. Exactly a year ago, this time at the summit, in the keynote, Matei Zaharia open sourced the Unity Catalog project. And here we are here to talk about what happened in the last 1 year, the fun stuff we have been building, and everything under the sun related to Unity Catalog open source project. So, to introduce myself, I'm an engineer at Databricks. I have been working on the Spark ecosystem for a long time. From RDDs, Spark streaming, structured streaming, Delta Lake, have been involved with all of them since their beginning, now also involved with Unity Catalog.
And I'm Ben. I'm one of the core ML Flow maintainers. It's usually nothing to do with Unity Catalog, but we also do open source support for ML packages at Databricks. And one of the packages that we support is Unity Catalog AI, which I'll talk about a little bit throughout this presentation.
Awesome. Okay, so we're going to talk about from the basics. What makes a great catalog? And why is UC? To motivate, why is UC the right catalog for you for the next generation of workloads? What can you do with UC today? And what have we been doing in the UC OSS project over the last 1 year? So let's start with the very basic first question. What makes a great lakehouse catalog? To understand this, let's first start by asking the question, what do modern data plus AI workloads look like? Because they're evolving, right? Today is a new world, Gen AI and everything, which means that all the technologies that are needed to support the new kind of workloads that are coming in needs to evolve to adapt to the new demands of such workloads as well. So what does a modern data AI workload look like? To understand that, let's start a company together. Let's sell some shoes. So imagine there's a website. I don't want to take any names, but myshoe.com, let's say, not Nike, not Adidas, myshoe.com, you have a website where customers can buy shoes. So you have transaction data coming in, and you want to build this back-end pipeline where everybody in the company, as well as end customers, can ultimately deal with the data that is coming in. So how would you traditionally start building it? You have transactional data coming in. You will have a data engineer, which preps the data, collects the data from various different sources, build up a ETL pipeline for bronze, silver, gold tables, takes the data, cleans it up, structures it, puts it in structured tables like orders, customers, etc., so that other folks like data scientists can generate more cleaned up versions, reports, etc., the golden layer of the medallion architecture on these tables. And then you have different sets of people in the company who want to read these reports, understand what's going on with our revenue, and are shoes selling well, how much profit we have, how much costs we have, et cetera, et cetera. So financial analysts want to look at those reports, et cetera. But now their job is to forecast that how is our business growing. So they want more advanced stuff, and that's where classic ML models come in. Like this we have been doing for a while, that I want to project the financial analyst wants. Here's the projections of demand and financial. So it goes back to the data scientist or the ML engineer and say, like, okay, we need an ML model. The ML engineer takes the greatest and best tools in the ML ecosystem and builds, here's a model. Financial analyst is happy. Okay, I can make projections and stuff. But that also means that there's now a growing set of reports, like here, like hundreds of tables people are dealing with, etc. Now, The CEO comes in, talks to the financial analyst. This is too complicated. I want it to be dumbed down. I want to ask simple questions. And then there are also customers who are asking, okay, they need customer service. Where's my order? Why is my order late? What's the ETA, et cetera. So all of these are customers going to ask questions. Warehouse managers, who's maintaining all the shipping and stuff of the shoes, they're going to want to know, okay, how much capacity do we need? How much do we need to reorder from the factories and stuff? How many orders are in transit, et cetera. And that's where the new Gen AI comes in. We need, today we want to build AI agents that can answer these questions without them having to deal with SQL or Python or all the lower level tools. Just ask questions and stuff. And so this is what a new age pipeline looks like from end to end. Let's see how we're going to build this. What are the technologies we will need? On the ETL pipeline side, there is the traditional technologies. You have to deal with tables. So there's Hive Metastore as a catalog, which may have different, you may have table in different formats. You have getting data, from some things in JSON, some things in Parquet, some things in a more modern format like Delta Lake or catalog or Iceberg. So a catalog has to handle all these different kinds of data, tables. And then these tables will be stored on cloud storage, S3, Azure Data Lake, Google GCS, HDFS, you name it. And then they will be having a plethora of different processing engines to process that data. Multiple tools, whatever you want to use, whatever tools is best for the job you need to do on the data. And then on the ML side, actually you should talk about on the ML side. He's the ML AI guy, not me.
Yeah, so when we're talking about what TD was talking about with regards to those forecasting models. So your data science team is going to build some, let's say they're building profit models. Relatively easy to get started. Maybe they do some stats model stuff later on or some deep learning approaches. When that team is building those models and getting ready to deploy them so that you can use them for analytics, it's very important to know what is in staging, what has been validated, and what is about to ship to production. So MLflow builds a native integration with Unity Catalog, both managed on the Databricks side, as well as open source Unity Catalog, directly so that you can manage access and promotion to different staging environments to eventually production. And when you're going to replace those models, you can then retire them and have a lineage tracking of that process. So it's super critical to have that as part of that's the MLflow Unity Catalog model registry integration. But also with AI agents, it's very important to make sure that we have the same sorts of rigorous controls about what is that robot effectively actually accessing.
Yeah, Ben, in fact, Ben, you actually jumped ahead that how Unity Catalog solves it. Let's understand in the world without Unity Catalog, you have these, previous Unity Catalog, you had these different sets of systems like MLflow, weights and balances that used to track models and registries that is completely different from Hive Catalog, right? So they're like two different worlds altogether. So there's the table world and there's the model AI world. And the two can never meet. Well, not never. That's the point of this talk. So, and then you have to deal with multiple different table formats. So Hive Catalog has been the de facto standard for almost 2 decades now. But technologies underneath the formats have evolved. Classic table formats, JSON, CSV, Parquet, these are still relevant, but they do not give all the things that a modern table workload needs. Like you don't get ACID guarantees, you don't get whether the data on the file system is actually in sync with the metadata in the catalog. All of these are problems that every data engineer has to deal with. And so that's why modern table formats like Delta and Iceberg needs more from the catalog that often the catalog is unable, Hive Metastore and this traditional stuff is unable to give. You need to evolve the catalog, the table catalog itself for these new age formats, to add new capabilities to it. And then if you zoom out again, every persona in this, there are like lots of people involved here. And you have data that everyone needs to access. But you don't want critical data to be accessible to everyone. So every person here needs different accesses, and the system needs to ensure that they don't have access to data that they shouldn't have access to. For example, a data engineer is creating all the tables, managing all tables. They need to have access to the bronze and the silver tables that they are working on. So they definitely need access to the data, but they don't need access to anything else, like more serious data like revenue projection, et cetera. They shouldn't have access to that. Similarly, data scientist actually needs access to some of the silver layer tables to generate the reports and stuff, but the data scientist should not have access to, for example, things like customer data, like that is PII data. Data scientists you may not want, as infrastructure provider, you may not want them to access to have that. Financial analysts, customers, they all need different access. For example, customers, they should have access to their own data. So if they should to be able to access and query their own orders, but not others' orders. They need to be able to update their own customer billing information or addresses or whatever, but not anybody else's. And they need to have access to the agent as well. Warehouse managers, again, a different model. So everybody has a different thing. But on the other hand, AI agent needs to have access to all the data because it has to answer all the questions, right? Mm-hmm. So the AI agent needs to be smart where, depending on who is asking the question, it needs to assume that caller's permission and only access the data that that caller is allowed to access. So this is a new world of access control that is needed to really secure the data, that it goes beyond tables and these traditional models. And the other problem I want to highlight is, even within the domain of tables or anything that is on the storage, today the standard is you need to configure your engine, Spark, Flink, whatever, with permanent cloud credentials, permanent S3 access key, secret key pair, things like that, permanently in your engine. And so it makes it much harder to change the access. You have to go update all your applications, update configuration files in multiple different places. If you want to change somebody's access, you want to revoke someone's access because the person left the company or moved to a different role, you want to revoke access. Those are definitely much harder because of permanently configured credentials. So to summarize, data and AI assets are siloed into different parts of the company, and it's very hard to share things between them or have an overall view of who has access to what. And so governance is fragmented, which increases administrative cost. And then modern table formats are not supported by the traditional catalogs. So you don't get sufficient transaction guarantees until you do a little bit more. Or you can get, for example, Delta Lake, you can get transaction guarantees, but there's a risk that your catalog and the Delta table on disk may be out of sync. So our goal while building this Unity catalog was to give users the flexibility to use data and AI assets without sacrificing security, to have a single pane where you can look at the Unity overall and see what are all the assets that are present and how am I able to govern them. So Unity catalog started as a multi-format from day one, multi-format, multi-modal, and a unified platform. Let's walk through the problems once again. So we are taking from these disjoint silos and having Unity catalog be the single source of truth that tracks all assets, from the tables to models, as Ben was talking about a little bit earlier. And then all accesses from every person, every engine needs to go through UC so that UC can dictate whether you should have access or not have access. It can do the access control in one single place. And so therefore you can control it from one single place. And then for UC to have this level of control, you need to be able to trust UC. UC is a trusted entity where you're putting all your security policy in UC, which also means that UC should be the right person to dictate whether a particular user or a particular engine that needs to access the table should have access or not. So the UC is the one which will do vend credentials, temporary credentials to engines, such as Spark, to access the tables based on the user who has queried. For example, if the warehouse manager wants to query about order data, he is only allowed to query orders. So only queries that are about orders and nothing else, not customer data and stuff, only those queries, UC will say you're authorized to, the Spark query is authorized on behalf of the warehouse manager to query the order table, so Unity Catalog will give it temporary credentials and while the Spark, just for the duration of the Spark query. I'll go into details later. And then the third problem is better support for modern formats. So we're building in Unity Catalog new APIs that will allow Delta Lake, Iceberg. Iceberg already has a REST catalog. We support Iceberg REST catalog within Unity Catalog, REST catalog AP spec within Unity Catalog. But we are building all this additional stuff that is needed for modern formats to have more support for transactional updates while keeping the catalog in sync of what all is going on, or all changes going on in the table. So if you're changing the schema of your table, your catalog schema will also reflect what is the current schema of the table, without losing support for existing classic formats. So you don't have to choose that I will pick only this format and nothing else and stuff. So give you the maximum flexibility. So we have unified data and AI assets, we have unified governance, and we are giving modern table formats the support from the catalog that they need. And so in this talk, we're going to cover not everything, but this is the high-level overview. The goal is to provide governance, discovery, eventually lineage, monitoring overall across all these different assets, tables, views, volumes. I didn't go into volumes, but functions, models, some of these we're going to go into. So what can you do with UC OSS? To understand UC, you need to understand the object model. How are these different data AI assets stored in UC? We have the catalog that is, there's a 3-level namespace. So you can have any number of catalog objects, my catalog 1, my catalog 2. Inside each catalog, there can be any number of schemas, databases, and inside each schema and database is equivalent term here. And inside the schema, you can have tables, volumes, models, functions, other things. And then independent of this 3-level namespace, there are other objects that are also present. There are things like credentials and external location. I'll go into detail. I'll walk through them. But they are important for that goal of the UC being able to have access to all the data or all the storage so that it can selectively vend access to engines on a temporary basis. We'll walk through that. So for tables, let's start with the basics. What does a table entity look like? So at the very basic level, it has the properties it has is it needs to know it's part of a catalog, it's part of a with schema, it has a unique identifier, it has all the column information, like what is the tables schema, what are the columns inside it, properties, what format is it, CSV, JSON, Parquet, Delta, what type of table is it external or managed, like there are definitions here, is it fully managed by the platform that UC is part of, or is it something that is external to it and UC does not have full control over it, or views. There are different definitions. I will not go into detail, but ultimately, one of the most important bit is the location of where the table is. And so you can have there's a hierarchy in the catalog that ultimately points to the hierarchy in the cloud path where the table reside. And then there are APIs that UC provides, REST APIs, where there's also SDKs and stuff, that allow you to operate on these tables at the metadata level, not at the data level, because engines are supposed to operate at the data level. The engines will ask the catalog to get the metadata of the table before operating on the data. So to create the standard CRUD operations, create, get, list tables and stuff. But the interesting bit we have added here is you can ask UC to generate temporary table credentials. And as I said, for that to work, UC needs to have full access to the cloud store. It needs to know how any user can access the cloud, and UC must have full control. And so for UC to know that, these are the two additional entities that you can populate in UC. For example, if you are let's say, administrator, and you want to configure that all the tables in this particular catalog, let's say my catalog, let's say I was using my catalog, my schema. So say I'm an administrator, I want to set up that all tables in my catalog is going to be located in this particular S3 bucket. So as an administrator, I will configure this as an external location and a credential. So external location it points to the path of that S3 bucket where all the tables will reside. The credential is things like IAM role, etc., that the UC can assume to generate credentials for reading, writing within that bucket. So the UC has the full knowledge of this. Now, using these two information, so the steps to configure UC for working with tables, as that all of this works, is first you configure the credential, you configure the external location and link it with the credential that using this particular credential, you can access the external location, and then you can start defining tables in that particular catalog, which is using that external location. So let's look at the steps. When you ask UC to create a temporary credential, let's say I want a temporary credential for my Delta table. What UC would do in the background is that first of all, it will authorize if the user, as a user, you're providing Spark, here is my personal access token or OAuth token. Spark will forward that to the catalog and say that I want to get credentials. I am this user, I want to get credentials for accessing this table. First of all, UC will check, is this user valid? Does this user have access to this table? So authentication authorization. I won't go into that detail here. But then the UC will look up, here is the location of the table. It needs to match the location of the table with any of the external location. Is my table present within an external location or not? Once it finds the match, then it knows that, okay, UC has the capability, the corresponding my credential and external location, it has the capability to actually generate a new credential that gives that user or Spark, masquerading as the user, access to only the Delta table on a temporary basis. So just to be clear, that UC has access to the entire bucket, but the user should have access only to the Delta table's location. So UC generates a scoped down credential, which is time limited by, let's say, 1 hour, and gives it to the Spark engine or whichever engine you are working with. And that engine uses that scoped down credential to access only that table it should have access to and nothing else. And that's how temporary scoped down credentials work, and that's how you have governance. And so if you are an administrator and you want to revoke access to a user, you update UC that this user should not have access to this table anymore. After the temporary credential expires, they will not get any new access. That's how UC has full control. In the interest of time, I'm not going to go through a demo for this, but I think there's a lot more exciting stuff going on the models and AI side. So, Ben.
Yeah, so just as TD was talking about with table access controls, as well as having a place to store securable objects that you really do care about, we have extended the same thing. Years ago, when we looked at what Unity Catalog built, the MLflow team, we said, well, this actually solves a lot of our problems. Why would we go and build our own thing when we can just use this? So that's what we did. We actually used that entire structure to store what you see on the right-hand side here, which is basically a typical model architecture structure of the serialized state of a model in MLflow. Anybody in here ever used MLflow? Raise your hands. A couple people? Yes, more people. So when you look into the MLflow UI, you actually see this. So you can actually take that entire data structure, send it to Unity Catalog, and have the same functionality in MLflow with stuff like promoting from different locations. Like I have a couple of things in dev, I want to push it to staging. You can use UC to control that and actually provide access controls for doing promotions across places. So it's super important. Extending from that, we also looked at what Unity Catalog built with some other cool stuff. So functions started off with tabular access. It's a way for you to define a user-defined function in a couple of different code languages of your choice. We got, most people use it for SQL historically, and it's great. It's got the ability, like required things like you have to define your catalog, your schema, the actual function name, and there's a bunch of optional things, metadata that are in there that became important for us later on from when we wanted to do the Gen AI stuff. But the standard APIs that are there that are part of Unity Catalog, they make a ton of sense for what most people were using it historically for. I need to apply custom logic to a table in order to get an answer to a question that I have, and I need that to be secure. But when we moved over to the Gen AI era, go back in time about a year and a half, we start looking at what capabilities are there for interfacing with an LLM. LLM, you talk to it, they tend to make stuff up quite a bit, right? So over the last couple of years, people have been trying to extend the functionality and capabilities of LLMs by giving them access to deterministic tool executions. So we wanted to build the same thing, right? Like all of our users wanted that on MLflow. So instead of us going and reinventing the wheel about, how do we build a serialization platform for this, we looked at UC because it had most of what we needed. Now, for the typical basic use of these UC functions, we just kind of define, say, a Python function like this, like you see on screen. We have a name of that function. It's going to get registered to a catalog and a schema and registered this function name. And applying this to a data table, Spark is going to intelligently know, or whatever your execution engine is intelligently going to know how to execute this Python code. It doesn't need to really understand anything external to it because you've already defined what the type interface is. So if it's operating on, in this case, we're operating on a string. Doesn't really matter what we call this function. It's irrelevant. Like as a user, we're the one calling it. We should know by looking at the code what it can do. However, when you hook something like this up to a Gen AI agent and tell it, hey, I have this function definition and it's called sanitize input, it's going to infer what the functionality of that tool is and decide whether or not to use it based solely on the name. So there's no metadata here that really tells what's going on. So what I'm simulating here at the bottom on this slide is a user asking a question, hey, on our shoe sales company, who's our most valuable user? Because we want to send some marketing information to them. And if this is the actual tool that it has, the Gen AI agent, it's going to reason before it actually does the tool execution. That's what it's going to basically talk to itself. It's like, hey, I need to clean up this data because I shouldn't be sending like PII data. And then it'll execute this function. And the actual agent doesn't look at the source code. It doesn't have access to it. It just has access to a name and hopefully some metadata about what that function's for. So it's going to return after executing. The agent is going to assume that it's already cleaned out all of the important stuff that this user shouldn't have access to. But as we can see, it gives all the information you would never want to display about a customer. Now, in the Gen AI world, we actually need that additional metadata. We need to know what the function's name is, yes, and when we're talking about UC function storage, we need to know the catalog, the schema, the function name, but we also need to tell it what is this function used for, what are its capabilities, what are the argument inputs that need to be used. Those are also required for standard UC functions, but in the AI world, or the Gen AI world, we need a little bit more information, so we need comments about every single argument. We also need types. And we need types because we're operating typically in Python, which is an untyped language, but we need to be able to convert between Python types and the backend JVM types. Now, once we have this registered and the actual agent understands what this function's for, it's going to know when to actually call this and what the expected output is. So in the event of this scenario, it would actually realize that it didn't actually sanitize anything but some strings, so it wouldn't even call this thing. Now, when we moved into building this out for real, because of the limitations that were in place because UC functions were never designed to do what we were trying to make them do, we realized that we needed to extend Unity Catalog. So we created Unity Catalog AI, which is an extension on the Unity Catalog protocols that provides an SDK interface that basically sets it up so that when we define a tool, AKA a Python function, in order for GenAI to use, it has all of the data it needs to know when to use it, how to use it, what the expected use of that tool is going to be, and then we do some validations as well. But it allows us to do a much more safe application. We know what it's going to be having access to. We know when a user interfaces with that GenAI agent, whether it has access to certain functions as well. Because just as TD said, we can set those controls as well. So you have a very sensitive function that's there that you only want a subset of your company to have access to. You can set that. So most users can still talk to the agent, but for that super special, highly secretive one, maybe there's only 4 or 5 people that can talk to an agent and have that capability in it. So with us building this SDK, it allows us to have the kind of the best of all worlds with respect to function execution in AI, data science, and the Gen AI era, where we can have a software engineer write a fairly complex function that can be reused pretty much everywhere. So a data scientist who's trying to create feature engineering sets for maybe traditional ML, they have this function that they need to execute and apply to their data. Before you see AI, that's code copy in multiple repos or in multiple notebooks, and it's a mess, like trying to manage that. I know, I used to do that. It's terrible, it's a headache. But with this, we can actually have other software engineers use that function. We can have the analysts, we can have like Tableau connected to these, Unity Catalog, and you can have visualizations directly just using this function that's been vetted, and as you see in the top right here, unit tested. We can have this set up so that as it's in Unity Catalog, we can have daily checks that are like, hey, run this against, this data that I have, make sure this function is still doing what I expect it to do. And we can connect it to an agent.
3 minutes.
What's that?
3 minutes.
Yeah.
Yeah.
Yeah, so the main thing about what this SDK that we built is, it's a translation layer. So the function, we allow it to translate into a way that we can write a Python callable into Unity Catalog. Then from there, we can decode that back into something that's human readable and an agent can actually use. And this is kind of a high-level overview of how agents actually use these tools. So we'll have this agent definition. It has an LLM. It has some tool definitions. But what we're actually doing is we have a client in the Unity Catalog AI SDK that allows us to define these functions, write them to UC, and then when the GenAI agent needs to actually access, like what functions do I have available, and how do I actually run these, that's what we actually built here. So it's the interface between magical GenAI stuff as well and deterministic function execution. So we're going to go through a quick live demo of seeing what this actually looks like. And what we're going to be doing is talking to Anthropic. Anybody here like a Claude fan? I know I am, huge fan. Claude 4 is awesome. So we're going to actually be doing that. And to set up everything, we, basically have to be running Unity Catalog open source. That was the I term that you guys just helped me check. I'm making sure that the catalog is up and running. And this is kind of what you're going to see when you actually do that. You're going to go to the root of where you have UC, Docker compose up, and it'll build it. We can go over and verify. We have the UI running, and we have, the default setup there. And here, all I'm doing is I'm basically contacting, Anthropic to say, what models do you have available today? Show me the latest and greatest. We have Claude Opus 4, we have Claude Sonnet. These things are things that just released relatively soon. And for this use case, in this demo, what we're going to be doing is asking Claude if it can estimate, based on some loan characteristics, if I make a monthly payment on my mortgage, when I'm at a particular rate, and some data associated with it, if I pay this, like overpay my mortgage, when am I going to be done paying my mortgage?
So fun questions like that.
And it's something that it doesn't seem super fun and exciting for a demo, but when you think about it, it's actually a useful tool. If you're like, hey, I want to know if I pay an extra $250 a month, am I going to save like 6 months on my total mortgage payment? And it seems like it's a trivial thing to answer, right? That, hey, a human can do that, no problem. The function for it isn't really that hard, compounded interest calculation. However, GenAI, even though it can write its own code, it's incapable of actually answering this question. The reason being, if Anthropic will answer me, it'll give us an answer. However, and it says right there, I can help you calculate when your mortgage will be paid off. It understands, it parsed all that language that we passed into it. It knew, even though I just wrote some arbitrary human readable question there, it comes up with some math here. It seems legit. And by the way, every time you run this, you're going to get a different answer, because that's how GenAI works. It'll tell you in different order of stuff. But it's going to come up with something. It's going to say, hey, my loan's going to be paid off in 117 months. And it says, hey, if you start it today, does anybody notice what's wrong with that? What it says? Today, December 2024, that's kind of a little far off. That was when it last was trained. So the latest date that this Claude model had was December 2024. It trained, they went through a bunch of fine tuning, they did a whole bunch of stuff, and then finally they released it in the end of May of 2025. So it has no idea what day it is. And it shouldn't really, right? You shouldn't have this thing connected to live services like that. But it's going to say, hey, around September 1st, 2034 is when, your mortgage is going to be paid off, provided all that stuff. But like I said, they make stuff up. I don't trust them. So what I did is I went and wrote this function. And you can kind of see it here on screen. We won't go over it, but it's basic math. But if we actually run this, we get May 1st. So we're off by many months. Even if we do the math of like adjusting, okay, that was like 7 months ago, and then added it again, it's off. Now, if we had more time, I'd run this 10 times, and we would see that every single iteration, it bounces around on what month it thinks. Does anybody know why? It's a fun little question. No? Okay, I'll tell you. Floating point calculations. So what Claude is doing, it's executing code, but it's writing basic JavaScript code, so it's using just floats in order to do this. This calculation is amortizing every month in order to do the calculation, so it's a recursive calculation. Those floating point errors propagate throughout that, so when you get a long enough time period horizon, it's way off. And it's going to adjust how it writes the code slightly differently every time, because it's just generating stuff. So it starts getting really, really, unstable.
So a whole different definition of variable mortgage rates.
Exactly, yeah. So what we can do is we can actually take that function that we just defined, and we could just write this to Unity Catalog. So I wrote that in Python. Now, UC Functions has the ability to store metadata about a Python callable so that I can execute it wherever I want. But with the Unity Catalog AI SDK, I can just pass in the Python callable with defining a Google-style docstring, type hints, and making sure that I have comments there so that we can extract all of that and store it in UC in a way that a GenAI agent, like Claude 4 in this instance, will understand what this thing is for. Now, even though we have that stored, we want to make sure that, hey, I wrote this, but I want to make sure that I actually wrote it correctly. So I can actually execute this directly in UC. And that's what we see here, this UC client execute function. That's part of the Unity Catalog AI SDK. And it gives us the correct answer.
We need to wrap up.
Let's just see what happens when we actually talk to Claude with the tool. It's going to say, instead of making a bunch of stuff up, it's going to say, I'll help you with this. But it's also going to say, I need to call a tool. And it knows which tool to call in Unity Catalog because we have that translation layer. And when we call it with that, it gives us the correct answer. So this is the power of GenAI with tools. And we can do this in a very simple way, where we can write a function in the way that we know how to write it, it stores it in a way that's not really human readable, but the GenAI agent can actually interface with it.
Okay. We are totally out of time, so I'm going to wrap up the rest of it very, very quickly. Let's switch back to the slides. So there's a lot of things we didn't get to. Ask us questions right after this. We are at our our growth of the UC project has been much bigger than anything I've ever seen, much faster than Delta Lake itself. We have lots of release going on, both in the main core line as well as the UC AI release line. We have over 500,000 downloads a month for things that we are releasing, as well as other companies are actually integrating with it as we speak on every month. This list is growing, and lots of future directions. Come talk to us in the Slack, on GitHub, et cetera, et cetera. So I wrap it up in 10 seconds. Thank you very much.